In this video, we're looking at reflections off a slab of flint glass. So I have a laser beam with an incident angle of 35 degrees. It strikes the glass right at this interface. And the first reflection comes off of that surface, but part of the beam is also refracted into the glass. We're told the glass has a thickness of 3.5 centimeters. Then that beam is going to strike the lower surface of the slab and reflect back upward. Then that reflection hits the air glass interface and refracts away from the normal. And now I have two reflections emerging parallel from this slab. So the ultimate goal of this problem is to figure out that horizontal separation distance d between the two reflections. But we start with part A, compute the angle of refraction, theta, for that ray entering the flint glass. So we quote Snell's law, and we're saying here that the index of refraction of air is about 1. So n1 is going to be 1. Our incident angle is 35 degrees. n2 for the flint glass is 1.63. And then theta is the only unknown here. So we divide by 1.63 and invert the sine function. And this gives me a refracted angle of 20.6 degrees. Now in part B, we want to get that horizontal separation between the two reflections emerging from the glass. And we're going to take advantage of symmetry here. I can see, because the reflected angle for that second reflection is the same as the incident angle for the second reflection, that I'm covering half that distance d as the ray goes down through the glass, and then the other half as it bounces back up. So if I isolate just the first half of that, I have a right triangle with this 20.6 degree angle known, and the adjacent side of 3.5 centimeters known, and the opposite side is d over 2. I can use the tangent function then to get at d, and the tangent of 20.6 degrees is going to be d over 2, that's the opposite side, over 3.5, the adjacent side. So we multiply both sides by 3.5, multiply both sides by 2, and we smash the numbers into a calculator. And I get that d is 2.63 centimeters, and we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the slab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.